Hello and welcome to lesson number 1 in unit number 1, linear relations in our grade 10 academic math class. This is graphing linear relationships. So this unit, called linear systems, I think, linear systems, it's about straight lines and how groupings of straight lines can interact. In order for us to be able to observe graphically how this happens, we need to be able to actually put straight lines onto the coordinate plane. So that's where we're going to start, is how do we graph a straight line given an equation. 3 methods that you learned in grade 9 we're going to review in our first lesson here today. So example A is already written out. Why don't you hit pause on this video, and when you copy this out, and then come on back when you're done and we'll talk through the first example. So do that now. Okay, you're back. Now, graphing using a table of values. Tables of values, they get a bit of a bad rap from people, I guess. It will work with any equation that you are given to graph. Anything at all, not even the ones you're just doing this year in grade 10. This will work for any equation you encounter in your whole math lifetime. It's nice because it works every time. It's a little less desirable because sometimes when you're just picking random numbers to input into the equation and seeing what it outputs, it doesn't necessarily give you points that are all that helpful. So that's the plus and the downside. Let's go over how it works. So we started over here with this equation, 2y equals 4x minus 2. In order for us to simplify this a little bit, what I've done is divide every term in the equation by 2. This creates an equivalent equation, and you'll see that the result is y equals 2x minus 1. You can see that it's a little bit, the numbers are a bit smaller, and we have an isolated variable sitting right here, which is great. So for us, what we're going to do is input x values, and again, I can't stress this enough, I'm just choosing arbitrary values. Now I tend to choose them around the origin, so 0, plus 1, minus 1, plus 2, minus 2. That's often where the action is going to happen in your math class anyway. So I've picked the numbers, and you can see them in the table over here, minus 2, minus 1, 0, 1, and 2. And then I'm going to just substitute those one at a time into the equation. So when I substitute, and I'll just do the first one here like this, when I substitute a minus 2 in there, so y equals 2, times minus 2 minus 1. Following BEDMAS, we do our multiplication first, and we end up with negative 5, y being equal to negative 5. So you'll notice that that is the value that I put into the table of values. So these are input values. These are the ones that you put into the equation, and then the corresponding y value is the output. So what we've created here is 1, 2, 3, 4, 5 ordered pairs, which it's listed up here. Ordered pairs we can plot on the coordinate plane. So we have minus 2, minus 5. Again, if we're looking for the way to plot this just from grade 9, starting at the origin, I go over 2 and I go down 5. 1, 2, 3, 4, 5. And there's my first point. And we do this, obviously, negative x values go to the left, positive x values go to the right, positive y values go up, and negative y values go down. So that is that's how you go about plotting points. Let me just tidy up the graph here a little bit because we just made a bit of a mess. Now things that you want to put onto a graph when you're finished labeling it are the x and y intercepts as well as the equation itself. If we're working in this unit through linear systems, it means there's often going to be 2 lines on the graph at the same time. That can get a bit confusing, especially because although I have colors, most of you will just have one color for your notes. So it can be confusing. So what I've done is I've labeled the equation. Now I've labeled this with the modified one that I made. You could put the original on, it'd be just as good. Now I do want to point out the y-intercept here is the place where it crosses the y-axis. And all points that cross the y-axis, they have an x value equal to 0. So it's 0 and negative 1. What that means is that it's moved 0 left to right, and then it's moved 1 unit down. So that is our y-intercept. Now you'll notice our x-intercept kind of falls between 2 points. Like here's 0, here's 1, kind of falls in between there. We're not exactly sure where it is, so because we're not 100% sure of what the actual point is, we're not going to label it. So in the case that it doesn't go through an even integer like negative 1 or 0 or 2 or something, we're just not going to label it at all. So that is our first method for graphing using a table of values. Let's move to the second method. The second method is graphing using intercepts. Now this is a little bit It's a little bit less than ideal because this particular method gives you only 2 points, and if you make a mistake getting one of those 2 points, it can be problematic. We're going to also, in this example, find sort of like a consolidation point, a point that helps us verify that the line that we've drawn is accurate. So how do we graph using intercepts? Well, this builds on the idea that when you have an x-intercept, you know that the y component is going to be equal to 0. In that it will not go up or down, it will only go left or right. It'll sit right on the x-axis. Similarly, and we just talked about this, the y-intercept will necessarily have an x value equal to 0. Doesn't go left or right, it only goes up and down, so it's right on the y-axis. So we're going to artificially create that situation so that we can graph those 2 resulting points. So let's do that now. We have 2x minus 4y equals negative 12, so we are going to choose to set y equal to 0 in order to find the x-intercept. So let's sub that in. We have 2x minus 4 times 0. I'm subbing that in because then the resulting x component will give me the x-intercept. 4 times 0, of course, is 0, so we have 2x minus nothing, so we'll just take that out. Here we have negative 12. To isolate x, we divide both sides by 2, and that's going to give us then x equals negative 6. So the point we're going to graph has a negative 6 value for x and the value that we put in for y equal to 0. So there's our first point, negative 6 and 0. Let's get that on the graph. I want to change up my color scheme a little bit here. So negative 6, that's over here, and again, that's 0. It doesn't go up, doesn't go down, just sits right on the x-axis. Now we're going to do the same thing for the y-intercept. In order to find the y-intercept, we set the x value equal to 0. So I'm going to substitute in, that's going to be 2 times 0 instead of x, I think it was minus 4y equals negative 12. So 2 times 0, that's going to give us 0. We now have negative 4y equals negative 12. In order to isolate y, we divide by negative 4. That gives us then y is equal to positive 3. So the point then will be 0 for x and 3 for y. Let's put that on the old graph. So we have 0, 3. That is our next point. 1, 2, 3. There we go. Now, our line, in theory, goes between these two and connects them. Now, it's hard to draw straight lines in the Notability. So I'm going to do my best to sort of just try to draw a line that goes through them. It's not an incredible travesty. That's actually pretty good. Sometimes it goes really bad. So that's looking pretty good there. We need to put sort of a second point in to verify this. We're going to do it in between the 2 dots just to verify the line that we've drawn is okay. Now I'm liking this point right here because it looks pretty close to minus 1, 2, 3, minus 4, and plus 1. So that's looking like a point that I want to verify. So what I'm going to do is I'm going to substitute in the value of negative 4 for x and see if we come out with plus 1. So again, just to talk through that, I'm looking at the line that I've drawn, and I recognize that this point here that I've just highlighted is pretty is on the line, and I'm going to verify it with some mathematics right now. So I'm going to sub in an x value of minus 4. Sub in x equals minus 4. So let's substitute that in now. So we have 2 times minus 4 minus 4y equals negative 12. And now we're going to isolate y. So let's work through it here. Here we have 2 times negative 4 is negative 8 minus 4y equals negative 12. I'm going to transpose negative 8 over to the other side by adding 8 to both sides. When I do that, I end up with negative 4y equals negative 12 plus 8 gives me negative 4. Now to isolate y, I'm going to divide both sides by negative 4. Y then is equal to 1. Therefore, that point that I put on is minus 4 and 1, which is indeed on the graph. So I've just verified that the 2 points that I put in are accurate. Let's do some labeling now. As I said, it's important to label your x and y intercepts. So there's our negative 6, 0, and the y-intercept is 3. Whoops, sorry, it should be 0, 3, 0, and 3. And now we're going to label the equation. That is 2x minus 4y equals negative 12. So there we go. That is graphing using the intercept method, or graphing using the x and y intercepts. We're going to look at one more method. It is the preferred method, and we'll be looking at that in the second part of this video. So we'll see you in part 2.